Alright, so ladies, take two. Today we're going to talk about the pH scale, and then we're going to talk about neutralization reactions, alright? Let me explain a little bit about the math behind the pH scale. I think you are familiar with it from previous grades, understanding how to read it, understanding what neutral is, what's acidic, what's basic, but today we're going to talk about the actual math behind the pH scale, okay? What does pH mean? What does it refer to? Yeah, it's concentration of hydrogen, okay? Or hydrogen ions, right? The pOH scale, have you ever heard of the pOH scale? Well, guess what that is? It's a measurement of the hydroxide ions. Now, concentration. So, if you see this in any of these formulas, remember that H3O plus will dissociate to release what? H plus. So this H3O plus is just simply a measurement of the hydrogen ions, okay? So if you come across H3O plus, remember that's just a measurement of the hydrogen ions. So to understand how to use the pH scale, you have to understand log function, alright? So the pH scale is a measurement of the concentration of hydrogen ions in moles per liter. Okay? In moles per liter. So let's say we have, because we've been talking about concentration, right? Let's say we have the concentration of H3O plus or hydrogen ions in a solution. Let's say the concentration is 1 times 10 to the negative 5 big M or moles per liter. Okay? What is the pH of that? Right? Now the formula for figuring this out is quite easy. You take the log of your concentration. So let's do that right now. Okay, come on, calculator, let's go. There we go. So we have a concentration of 1 times 10 to the negative 5, right? So 1 to the exponent negative 5 is 0.00001, right? Now, if you take the log of that value, you get negative 5. But the formula is, the pH is the negative log of a concentration. So in other words, you can see that you got negative 5. So here's your negative 5, but it's negative of that negative. So what's negative of a negative? Positive. So the pH is 5. Alright? pH is 5. Now I'm going to show you the opposite. Because, you may be asked to calculate the pH from the concentration, or maybe you're given the pH and you want to know what the concentration is. So, are we okay with log function then? So, really simple question. Imagine I gave you a concentration of, let's say, for instance, the concentration is of hydrogen ions. Let's say it's 4 times 10 to the negative 6 big M. Let's say that's a concentration, right? So what do? Well, according to this formula, you take the log of that, and then you multiply by negative 1. You take the negative of that value, right? So let's see what that is. So we have concentration of 4 times 10 to the negative 6. So we have 4 to the exponent 6 negative. And we got 0.00004, right? So, first thing, take log of that. Yes, so we're good. Then we take the negative value of that. Okay, so you can see in the answer it's going to be pH of 5.4, right? Because you get negative 5.4 at the negative value, that's 5.4. So that's how you go from concentration to pH. Now, you can go the other way around. If you have the concentration, so if you want the concentration, you have the pH, but you want the concentration. So in this case, you have the pH. You can see here. How do you get a concentration? So now you do the opposite. First thing you gotta do is you gotta get rid of the negative sign, right? So you can see that we get rid of it here and move it to the other side. So 3.5 becomes negative 3.5. And then all you do is take the inverse log. Now, here's the problem. This is where I made the assumption last class. I assumed everyone understood what that means. Your calculator may have inverse log function on it, but it may not. If it does not have inverse log function, then the inverse log is the button that says 10 to the x. That's the inverse log function. Okay? Let me show you what I mean by that. Here's my calculator. There's no inverse log function on this calculator. I don't see a button that says inverse log, okay? Unless I'm missing it. So let me give you an example. Let's say 1,000. What's the log of 1,000? It's 3. If I do the inverse log, or if I do the inverse of this, I should get my answer back, right? Right. So 10 to the power 3 is 1,000. So the log of 1,000 is 3. The inverse log of 3 is 1,000. Yep.
Why are you taking the inverse?
It's just it's a scale of 10. Now, why are we doing this? Because if you think about what we did with determining pH, we took the concentration, and what did we do with the concentration? We took the log of the concentration, right? To figure out the pH. Well, what's the reverse of that? Well, we've got to take the inverse log. So, what is then the concentration of a solution that has a pH of 3.5? So we take the inverse log of 3.5, which would mean then basically it's 10 to the power of 3.5. So we go to a calculator. It was all right. 3.5. What's 10 to the power of 3.5? Well, that is, I don't know if you can see that, 3,162. Sorry, I apologize. It's supposed to be negative 3.5. Forgot that. Okay? Because remember, it's a negative sign here. So let's do that again. Where's my calculator? Calculator disappeared. Oh. Did I delete it? I must have clicked the X. Alright, sorry. It's negative 3.5. So negative 3.5. Alright. So it's 3.16 times 10 to the negative 4. Alright. So my concentration is 3.16 times 10 to the negative 4. And again, that's big M, okay? So, let's look at a few examples of that, okay? And I just want to point out one thing about because we are focusing on the pH scale. The pOH scale is, you measure it the same way, using log or inverse log, depending on what you want. And there is a correlation between the two, by the way. They both actually add up to 14. So if you know the pH of something, you also know its pOH. So if you have, for instance, a solution that has a pH of 3.5, then its pOH has to be 10.5 because those two have to add up to 14. Yeah. Which makes sense because if a solution is neutral, what's its pH? So what's its pOH? So if pH is the concentration of hydrogen ions and pOH is the concentration of hydroxide ions, they're both the same. So let's just look at maybe one example, okay? So let's look at a pH of 11.7. How do we figure out the concentration? So remember, you take the inverse log, right? So it would be 10 to the power of negative, don't forget to put the negative sign. Because if you look at the formula, the pH is the negative log. So if we want to get rid of the negative sign, we got to move the negative to the other side. Then it becomes positive. That's a great question. Yeah, I'll mention that in a second, okay? So the question was, what if the pH is negative? We'll look at that one next time, okay? So what's the concentration of a solution that has a pH of 11.7? So the inverse log is 10 to the power of negative 11.7. So what would that be? 2 times 10 to the negative 12. And that's big N. Again, this is the concentration of what though? Hydrogen ions, right? What would the POH be for this solution? Well, they have to add up to 14. So it has to be 14 minus 11.7, which is 2.3. So the POH is 2.3. How would you do the concentration? Exactly the same way. It's 10 to the negative 2.3. So what would that be as a concentration? What is it? 5 times 10 to the negative 3 big N, right? So this is the concentration of hydrogen ions, and this is the concentration of hydroxide ions. Now, someone asked a great question. What if it's a negative value? So let's imagine that we had, so here's 2.5, okay? Let's imagine that it's negative. Because you could have a negative pH. It's possible. So let's imagine that it's negative 2.5. So then what would the concentration be? So it would be 10 to the power of negative pH, right? So that would be 10 to the power of negative times negative. So that would be 10 to the power of 2.5. 316? Big M. Now, to be honest, I don't know if that concentration is possible, but you could get a negative pH. So it still works the same way. Okay? So that's the pH scale. Any questions about the pH scale, about POH scale, how to use it, how to calculate concentration, how to calculate pH from concentration? All you gotta know is two things. One is log, and the other one's inverse log. Very, very easy stuff. Correct. Correct. All right. Now, let's look at some neutralization reactions. Okay. So we talked about the pH scale. In a neutralization reaction, so our next thing we'll look at are neutralization reactions. This is when you have an acid and a base reacting, basically trying to cancel each other out. If it's completely neutralized, your pH will be 7, right? So let's make the assumption that it's completely neutralized in this scenario, okay? So you have a student that has a solution of HCl, and it's going to react it with a solution of NaOH. And we want to know how much NaOH do you need to neutralize the hydrochloric acid, okay? So now this is really no different than what you've done before, because it's still a solution. So we're going to use the exact same things that we talked about before. Like first off, you write the equation out, right? So HCl plus NaOH would give you NaCl and water. So that's the first step. Now, we could add a little bit more because now we know the subscripts. AQ, 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 liquid. So first you write down the equation, then you balance it. In this case, it's already balanced. So this says that for every 1 mole of HCl, you will need 1 mole of NaOH to neutralize it. So the next step then is looking at, well, how many moles of HCl do you have? So let's look at the HCl, and let's figure out how many moles we actually have, okay? So what information do you have? You have the volume. The volume is half a liter. You have the concentration. And now we can figure out the number of moles as C times V. So C times V, and that would be 0.5 times 0.5, and that's 0.25 moles. That's, something we've learned before, right? So now we know that we need 0.25 moles of sodium hydroxide because the ratio is 1 to 1. So if you have 0.25 moles of HCl, you need 0.25 moles of NaOH. We have the number of moles. We have the concentration. We're told that it's 2. So now we solve for V. If you remember the equation, C equals N over V. V would equal N over C. So 0.25 over 2 would be 0.125 liters. That's it. Now, word of warning. And this is not something you're going to deal with in grade 11. In grade 12, you will deal with this. Here we looked at a scenario where the acid and the base are both strong acids and strong bases. Now, what that means is that when HCl goes in water, it will dissociate into what 2 ions? Basically, H plus and chloride, right? Cl minus. Because it's a strong acid, that means that all of it will dissociate into those ions. If it's a strong base, all of it will dissociate. But if it's not, if it's a weak base or weak acid, then not all of it will break up. That's something you'll talk about in grade 12. So I'm not going to worry about that right now in grade 11. Because you can kind of see the problem, right? You can kind of see that if I have a strong acid, for instance, in this case, if I have a strong acid like HCl, I can figure out how many moles of HCl I have, right? I have 0.25 moles. And I know that I will have 0.25 moles of hydrogen ions and 0.25 moles of chloride ions, right? But if I have a weak base, then I gotta remember that my base will not completely dissociate. So I can't expect the same amount to neutralize the acid. I need more of it because not all of it is going to dissociate. Most of it won't. And again, but that's something that you'll deal with in grade 12. So in grade 11, we're going to talk about just only worrying about calculations with strong acids and strong bases where they all dissociate, and you can just use the concepts that you learned in chapter 8 and 9 with solutions and concentrations to solve these questions, okay? So let's look at one more question, and then we'll be done with it. Right. Okay, so here's your next question. I'll pause it, Okay, last question. So we have a student who wants to neutralize a solution of calcium hydroxide with nitric acid, okay? So, same concept. First, write out the equation. So, calcium hydroxide plus nitric acid, tomato, tomato, becomes calcium nitrate and water. We can add our subscripts. So make fun of your parents when I'm recording, and they will hear this. Okay. How is it balanced? So I need 2 here and a 2 there. Okay, now it's balanced. All right. So you can see that, again, these are strong acids and strong bases. So we don't have to worry about this problem with dissociation. So that means, in this case, 1 molecule of calcium hydroxide will react with how many molecules of nitric acid? 2. Okay. So let's first start off with calcium hydroxide and determine how many moles we have. So we're going to look at the number of moles. So what do we have? We have the volume, 0.125 liters. We have the concentration, 1.4 big M. N equals C times V. So what would that be? Wrap the 0 point. Perfect. So now we have the number of moles. Okay. Very good. So for nitric acid, we have 0.175 moles of calcium hydroxide, but you would need double that because the ratio is 1 to 2. So you would need 0.35 moles of nitric acid, right? So now we have the number of moles. We have the concentration. We're told it's 5. So what's the volume? Volume is N over C. 0.35 over 5. So I believe that's like 0.07. That's it, right? 0.07 liters. Okay? That is it. The end.